Okay, good morning, everybody. Thank you guys for being here. I know it's a little bit early, but and after 2 days of way too much fun, so I appreciate everybody being here on time. And this is also now the time, if you're not supposed to be in the extract, transform, and load class, and you're supposed to be in PLP or PLE, this is the time to vacate the premises. But this is the most interesting tutorial, so you may as well just stay here. And what we're going to be learning today about is how to actually ETL your raw data into the common data model. And we're going to actually do some demos with our tools. So I passed out those white rabbit candies. A lot of our tools are named after a rabbit. So white rabbit, rabbit in the hat, and usagi is actually the Japanese word for rabbit. And so we're going to be learning about those tools today. You heard about the book of Odyssey. These are definitely resources that are important to us when we're doing our ETL. And we're going to do some ETL examples. And this is, don't hold us exactly to this. This is about how the day will work out. So we're going to do a little bit of an overview. And I'm sorry, this will probably be repeat for some of you, but we'll talk about Odyssey and how we started. We will talk about designing the ETL. Then we'll talk about mapping with the vocabulary, which is a really important piece to understand when thinking about your ETL. Then we'll actually, after lunch, we'll switch and start talking about how to actually develop the ETL. Quality control has been a really important topic this year, and we'll talk about that and touch on the data quality dashboard as well. And just because you build your ETL doesn't mean you're done. You then enter maintenance phase, which is a really important phase to be thinking about. And basically, your work is never done when you have a CDM, so you have to continuously be working on it. And then we'll conclude for the day. Now, one of the things that I have on this agenda is we have built in some decent breaks. We found that even when we give people 15-minute breaks, 30 minutes later, they're coming back. So we are going to allow you to have a good 30-minute break. What I'm going to ask is when we break, that you come back before the 30 minutes are over. So we'll give you guys some time, but then let's reconvene at the expected time. We are also recording this presentation. So usually what this means is I should try to remember to repeat your questions so that the people who are watching the video later can actually hear what the questions are. But it's also good to just be mindful that we are recording. And although this doesn't happen very often, especially in the ETL class, sometimes people have very specific questions that are only pertain to their very specific use case. Sometimes we'll table those if it's not going to be beneficial to the broader class. So I don't want to upset anybody. This doesn't happen very often, but if we kind of go down a rabbit hole of something that just doesn't apply to most people, we'll probably table it. These are our instructors for today. So first we have Claire Blacketer. Raise your hand. Claire works at Janssen. She's an associate director, and she actually manages the majority of our CDMs within Janssen. So she is constantly working on the ETL process. My name is Erica Voss. I am also at Janssen, and while I used to work with Claire on the CDM process, I mainly focus on safety-based research now within our department. We have Evanette with us as well. Evanette is a principal data integration analyst at CHOP, or Children's Hospital in Philadelphia, and she works on PedsNet, and she's going to be talking a little bit about PedsNet this afternoon, which has gone through a massive ETL process. And then we also have Maxime, which is over there. Maxime is a software developer at the Hive, and he is doing a lot of work right now on White Rabbit and Rabbit in the Hat. And so he's a resource here to talk about some of the interesting developments that they're doing with the tools. If you are not already connected to the Wi-Fi, you're going to need to do that if you want to participate in some of the hands-on stuff today. So here's the network password and network and the password. I'm hoping by now you guys have probably looked at this. Also, if you want to follow along, we do have the PowerPoint online. I did update it last night with the exact content that was getting presented here today. If you pulled it earlier, it's 99% the same. But if you do want to get the current slides, there is our GitHub on Odyssey, which is the tutorial ETL. And within the GitHub, there's a materials folder. And then you'll see that there's a PowerPoint in there. Everybody good with that? I don't want to go too fast.
There's a lot of folders.
Yes, so do you see a material folder?
Yeah, but inside that one there's like...
But do you see at the bottom, there's a PowerPoint?
This one?
Yeah, it says like OMOP Common Data. Yeah, you got it?
Yep.
Okay. So before we actually begin with the content, we're going to do a little bit of teaser about Odyssey in the Box. So Odyssey in the Box is, we have created a virtual machine so that each of you will have an environment that you can play with today that has all the tools on it already. So you don't have to install anything on your personal laptop. And just so we are familiar with what's going on in Odyssey in the Box, we have a Postgres environment running on Odyssey in the Box, and it's got some CDMs running. We also have pgadmin 4, which is the software that allows you to talk to a Postgres database. We have the entire Odyssey stack already running, which means we've got Atlas and Web API running. There is R already on the machine, as well as some of the Odyssey packages installed. And then as far as what's in the database, we have some different data sets. You may have heard us talk about things like SymPuff and Cynthia. These are synthetic data sets that we typically use for our trainings. They're perfect because since they are synthetic, we don't have to worry about any rules around sharing the data because it's all fake anyway. And as well as the data, there's also the White Rabbit tool and Usagi. So what we want to do before we get the day started is actually log into these boxes. So the first thing that you're going to need to do is to kick off the remote desktop tool. So this is if you're running a Windows box. If you don't already know how to where your remote desktop application is, you can actually just go into the command prompt and get it to pop up. So this is for a Windows machine. Now, I am not a Mac person, but I've been told that there is a Mac remote desktop application that you can download. It's basically the same thing. And so what we're gonna want is, regardless if you're a Mac or a Windows machine, we want you to open up this application because this is what we're gonna use to talk to the virtual machines. So does anybody not know how to do that?
Is this the same that we use on Sunday?
Yes.
Probably, yeah.
Yeah, it should be the same.
They're clean boxes, so they haven't been touched yet, but it's the same idea. Oh.
On Sunday they gave us like an IP for each one.
Well, that's the next step.
Ah,
Yeah. So all you just have to
What
do
was
is
your
pull up the application right now, and then Erica's going to show you how to log into it.
What was your question? I'm sorry.
Oh, can we use the same IP?
No, so I'm going to give you guys new IP addresses. So if you guys pull up, once you have the remote desktop application open, please pull up this URL. And
Suggestions for Linux?
uh,
Ramino.
Yes, we're gonna go with, okay.
Use Ramino.
so the question was, what about Linux? So now we'll have to add a slide. And I guess it's Ramina is what we should be using.
Well, luckily we have Mr. Knight himself there for community support.
So when you open this app, what you'll notice is it's a list of IP addresses with username and passwords. And then there's a column that says like checked out to who, and checked out. So what you should do is pick one of the lines. It doesn't matter. They're all the same. And write your name next to the row. And essentially what you're doing is it's like checking out a book at the library. You're saying, this is the one that I'm going to use for the day. We have only 40 machines. So you want to not take more than you need. I'll just open up myself, just see how you guys are doing. The top machine is the one that we're using in the class. So please don't take that one. Is it not working? Oh, I just killed my presentation. Okay, hold on. Looks like. No, it should be fine. Hold on. I just opened it like an hour ago.
Is anybody else having trouble?
Should you be asking for a flash player update or something?
Could you guys try just copying the URL or? Yeah, I noticed that it's not letting me click on it, although it's not on the GitHub. I hide it. Yeah, I hide it in the presentation so that rando people don't start picking up our box. So if you guys type this in, it's not working. Let me try it myself.
Create like a real quick tiny URL.
Yeah, I'll try another one here. So I will. URL. Let's try this. Make it tiny. Where does it go? Is this it? Yeah. So guys, let me make it bigger. Can you guys try this URL?
That one works, for me at least. The other one crashed my phone.
Okay. Okay.
Yeah, it worked.
Okay, perfect. So let's each go in, write your name next to one of the lines, and then that will be your IP address. It also shows you that the username is Odyssey, and then there's a password associated to it. So we want to put that username and password into the remote desktop application and actually kick off the box. So let's see how people are doing. Okay, I'm going to move on. So I think we've gotten past this point. We've signed into our remote desktop. We've signed out boxes. And when you connect, it should look something like this. So we'll get back to this, but we like to get the drama of connecting out of the way in the beginning. So, okay, let's get started. So yesterday, George already teased this up. What is Odyssey's mission and vision? So our mission is to improve health by empowering a community of collaboratively generate the evidence that promotes better health decisions and better care. And our vision is a world in which observational research produces a comprehensive understanding of health and disease. And I really hope after yesterday's presentation, especially the part that Patrick presented, that if you're newer to Odyssey, that you believe that this is, we want to do this to improve health. It's not a business reason, or it's really to how do we get people answers that they need in times of, if they're in health crisis or have a health decision that they need to make. So that's our mission and vision. And when we're talking about the ETL, there's a lot of focus around our standardization. Our standardization, the backbone of our standardization is the CDM and the vocabulary. And so before the CDM and the vocabulary, the current approach, and for many people, still to this day, the current approach of how they do research is for every study and every question, we create scripts. So if you have a question that you want to ask, like, what's the adherence to my drug in the data assets that I know, that I own, you might have a method that you want to apply to your data sets. And so these are Christian slides, and so if you think of your method that you want to apply as some type of an appliance, like an iron in this case, you have this method, but then if you actually want to do something with it, you have to plug it into your data sets. Now, unfortunately, when you don't standardize your data sets, that means that every time that you want to interact with a data set, that you need a different plug. And in bringing the analogy back to like how we work with our data, it means you need a different program every time you want to ask a question. And so what that ends up looking like is that people basically take the iron and force fit it into all the different plugs. And that leaves us in a situation that's not scalable, it's not transparent, it's expensive, it's slow, and prohibitive to non-expert routine use. And so, for example, I worked at Janssen in epidemiology before we had the CDM, and I considered ourselves pretty good epidemiology departments, and the average study time was anywhere between 6 months to a year. So that's just to do one study. So the amount of studies that we could do in a year was extremely limited because there was all this time spent in programming against the data assets that we had. But then when you start talking about the CDM and the vocabulary, you bring in standardization. And so if you have methods that you want to apply, and if all your data looks the same, then you can just plug it in and use it. And what that means then is that you can have more than one appliance very easily. So if you want to do some mortality research or safety signal research, or if you have business-related questions, you could create methods to go against that, and then they just plug and play into your data set. So we're going to be focused today on the OMOP common data model and the OMOP vocabulary. Some of the other tutorials are focused more on the Odyssey tool, so population level estimation and patient level prediction. This also should look very familiar, although I feel like Patrick was like, we're not on it yet, but this is our current, we're getting there. This is our current version of the CDM, so CDM version 6, and this is what gives us the standardization. So I do want to go through and highlight some of the core areas within the CDM to make sure that we're all on the same page. So when you think of the CDM, what you're really thinking of most of the time is this section here, the standardized clinical data. And so this is where you're going to be storing information about people and then their drug exposures, the conditions they have, the procedures. So this is really where the bulk of your patient level data is going. But we do have some other things to facilitate the common data model. So for example, we have standardized health system data. So if in your data you have information about the location, so locations of hospitals or locations of where people live, we don't need to store multiple copies of location information. We can have singular sources of information about that. If you have information about care sites, we do the same thing. And then providers. One provider is going to have many patients. We don't need to have lots of records for an individual provider. We also have some standardized derived elements, and so the way I think about these is once you have a CDM, you can derive content from that CDM. So for example, we will take drug exposures and generate drug eras from this. So this is something that happens in post-processing. Once you've created your data in the CDM, you can run a job that will actually generate the drug ERA table. So it takes all of your exposure data, rolls them up to the ingredient level, and then looks to see how long are you exposed to that ingredient, given a little bit of administrative gap between things. Like maybe if you forget to fill your script for a couple of days, doesn't mean you're necessarily off the ingredients. This is also where, if you're using Atlas and you're generating cohorts, Atlas actually can write out to the CDM and store information about the cohorts that you have and the people that are associated to those cohorts. If you're in health economics, we have some health economic data like the cost and payer plan period. We also store metadata about our CDM. So the CDM source table is really important. This is going to contain information about what's the name of the database, what vocabulary did you run it on? What version is the CDM working on? When was the CDM run? Just high-level information so you can keep track of what's going on. There's also a metadata table. So as you learn things about your data source, you can store them in the metadata table. One of the things that we do in Janssen is as we do conversions, there is some decisions we make about what data we keep and what data we eliminate. And we will actually track in the metadata table some of the patients that we will drop along the way. And we'll talk a little bit more about what it means and why you might want to drop patients. And yesterday, I think Patrick mentioned that with, I think starting in CDM version 5, we started marrying the vocabulary with the CDM. So when you run a CDM, you need to keep that vocabulary with it because the vocabulary that you ran the CDM on really dictates what's going to happen within your data. And we're going to talk a little bit about that as well today. So a really quick high-level overview of the CDM. So why do we even care about the CDM? And we like to go through these a little bit just to, I think it kind of like sets the stage for why to even think about an ETL. Now I know if you're in the ETL class, you're probably already a little bit invested on generating a CDM, but what I think is interesting about this slide is different people have different reasons for investing in the CDM. And so it's interesting to kind of think about why others might go down this road. So one of the benefits of converting to the common data model is the ability to pursue cross-institutional collaborations. And so yesterday we heard about the WU study, and that's a perfect example of a cross-institutional collaboration. So with just a bunch of ladies on the phone, and we created a study, and we wrote a package, and we just sent it out to the universe. And then whoever decides if wants to participate, because they have a standard data asset, they can just run it and then send us back results. Everything's standardized. And so if without a CDM, even if you have the same data assets that you've bought for a vendor, so for example, if you buy IBM, your IBM might look different than my IBM. So that's how difficult it is on the non-standardized versions. If you're in the CDM, we're all speaking the same language. I think it's obvious that now when you convert to the common data model, you can have one program and run it on multiple data assets. So at Janssen, we have 13 different CDMs. So when we write a study, we have the ability to run that study on all 13 CDMs. And what's nice is then we can make the decision of what CDM does it make sense to run on, and then just run it when we need it. The vocabulary has greatly increased our ability to find relevant codes. We're going to talk a little bit about this today when we're doing the mapping exercise, but the vocabulary actually dictates where things go within the CDM. So everything in the vocabulary has a domain, and the domain tells you where that record needs to be put. So an example is when you're working in claims data, sometimes in the diagnosis fields, there will be procedures. And so just because it came across in a diagnosis table, in a diagnosis field, doesn't mean we should just put it in condition occurrence. The vocabulary say, I know that this is a procedure, or I know that this is a drug, put it in the right place. So what that means is that when you create concept sets from the vocabulary, you know exactly where to go look for it. You don't have to guess that, oh, I might have a drug, but it might have popped up in the condition table because I'm looking at a claims data. You don't have to do that anymore. One thing that I really believe in is that when you do a CDM, you actually truly know your data if you ETL a data asset into the CDM. So if I considered myself pretty well versed in the Truven assets or IBM Now and Premier before doing CDM. But in reality, if you're just doing studies on the data, you're only touching a bit of the data. You're only touching the surface of the data. And a lot of times when you're going in and looking for a particular disease or condition, you're not seeing the bad parts of the data. When you ETL your data, you start to see the bowels of what's wrong with the data. You see people who have multiple genders. You see people who are born after they died. And it's really because when you run all the data through a program, you start to unearth these things that don't make sense. And then you have to think about how you want to handle them. What I would say is through doing conversions, we've taught our data vendors about their data because we've had to kind of force the data through, and we've seen some wonkiness along the way. If you know a problem about your data, you can use the ETL to address it. I think this is really critical because one of the problems in our field is that there's nowhere to really go and learn and just become an expert on a data set. It's getting in there and having experience over time. Do you know how to actually use the data asset? And it's really hard to teach somebody that. However, through the ETL, if we know there's a problem that we have to address every time, we can just address it in the ETL processing. So for example, one of my data assets, we know that a very small percentage of the patient IDs get reused. And there's no way to disentangle patient A from patient B. But you can see that it's happening. And so what we do is we've determined for this 0.0001% of our patient population, we're just going to drop the records. And that way, the new analyst that comes along that doesn't know about this issue never needs to worry about it because we've handled it for them. We know it's a problem, and we've dealt with it in the ETL. The whole community of researchers across diverse organizations and countries. Because we all speak OMOP Common Data Model and we have similar methods, it's really easy to interface with other people within OMOP and talk about research. And we do this all the time at Janssen. We'll reach out to other people in the community who might be experts. So for example, I think Rupa yesterday talked about working with PedsNet to do a study because at Janssen we needed to know a little bit about pediatric data, and we didn't have any data assets that helped us with that, so we reached out to CHOP. And because we all speak CDM, it's not a huge burden for us to go to CHOP and say, hey, I've written a program, can you just run it? Can you see that you have these patients? Do they exist? And ultimately, it's a beneficial relationship for both of us because CHOP wants to help its patients, and we want to make sure that we're finding patients that might have a need met by maybe one of our products that we're developing or a trial that we want to go after. When you have data in the CDM, you can use standardized tools. So like I said in the other classes, they're talking about patient level prediction. You can't write methods like that if every data asset looks different. And you can't have fun tools like Atlas if every data asset looks different. The CDM brings consistency to observational research through standardization of many of its components. So for example, if I'm performing a research study, through Atlas, I can, in a standardized way, pull cohorts. So the way that I pull a cohort is going to be very similar to the way somebody else in my group pulls a cohort. So you're taking away that inconsistency that used to happen between your analysts. Even if you had two very good analysts, they're going to tackle the problem very differently. And through standardization, we can eliminate a little bit of that variability. There's a buy versus build. So everything in OMOP in Odyssey is free. So we hope that makes people want to get on board. There's no cost. And we believe in Odyssey about going towards open science. We believe in transparency, and we believe through these tools, it makes it easier to be transparent. So what is an ETL? I'm assuming that a lot of you guys are aware if you've joined this class today, but just in case you don't know what it stands for, it's extract, transform, and load. And it's really all about this journey that we need to take from our raw data asset and getting it into the common data model. And it can be a little bit of a convoluted journey, and it depends. As you mature, you might make it more complicated, but you can start with it being very simple. And you don't have to be very complicated. And part of this job is not only standardizing the format, but it's standardizing the vocabulary. So your data asset might speak ICD-9 or ICD-10. We want everybody speaking SNOMED and ArcSNorm. That way we're all kind of speaking the same language. So today we're going to talk about how to design the ETL and CDM. Because every organization can kind of tackle their ETL a little bit differently, this is not a class to teach you how to program your ETL. We'll give you some ideas about how to go about that, but every organization is going to have different preferences in what they do. So we're not going to be teaching how to program today. Okay, so at a high level, when you're getting started with an ETL, this is the process that we go through. And we created this process probably about 5 years ago now. It really has withstood time. And we found that regardless of how many times we go through this, if you kind of walk through it in this way, it makes a cleaner ETL in the end. So the first thing that we recommend that people do is get data experts. So this is the people who are good with the data asset that you want to convert to the common data model. It's also probably good to have a few people who at least know what the common data model is in the room. So getting these individuals in the room, this would be a way to start developing the ETL. And today we're going to go through tools that will help facilitate that conversation. Once you've kind of gone through the ETL design process, I would even say part of that design process might be working with people who have experience with medical terminology that might need to help you with some of the coding. The vocabulary does a wonderful job of coding a lot of the things that you probably already have in your data assets. But I'm going to guarantee that pretty much every data asset might have one or two things that are not in the OMOP vocabulary. And so you might need to go down a vocabulary exercise to get it to standardized terminology. And we have tools to facilitate that work as well. So once you've gone through and you designed your ETL and you've done your mappings, you've essentially ended up with an ETL document. So this is saying, this is what we want to do. Once you have your document, you can give that over to a technical person to implement the ETL. And I specifically say technical person because at Janssen, for example, we started with epidemiologists trying to execute an ETL. And it's just not the right expertise to move terabytes of data through an ETL process. You really want somebody who maybe has experience in that process and knows how to make it fast and knows how to work with data, because it will just be faster in the long run if you have people who have that technical expertise. And then once you have the ETL, you actually need to test it, and then you start going into quality control. Sorry. So you can see below, all these processes are facilitated by different tools within the Odyssey framework. So we have the White Rabbit tools, Rabbit and Hat, Usagi, Achilles. We premiered the DQD dashboard yesterday. And so as we work through this process today, we'll show you how these tools integrate. So this whole lecture has been based on some documentation that we've put around this process. So, and that documentation actually now is in the book of Odyssey. So essentially everything I'm telling you today is in the book. So, but this is more exciting than reading it. But if you want to go back and refer to this, the material is this in chapter 6. Okay, so the hands-on exercises that we'll do today is we're going to scan a database with a White Rabbit. This tells us a little bit about what's going on in our raw data sets. Even if you're really familiar with your raw data set, you'll learn some things when you scan it with White Rabbit. We'll practice building a document with rabbit and hat. And then we'll do a mapping exercise with the OMOP vocabulary and Usagi. Okay, so let's get started with step one, and this is where we're gonna actually start to build our ETL map. So we had sent out an email about reading a patient's story. So one of the things that we've learned of doing this tutorial over the years is everybody in this room probably has different experience with data, and people have experience with different types of data. So if I got here and taught a lecture about claims data, I'm losing half the room automatically because not everybody works with that. Or if I got up here and taught a lecture about EHR data, I'm gonna lose the other half of the room. So what we like to focus on is instead on individual patient. That also makes it really tangible because we're only thinking about one person. So today, throughout the tutorial, we're gonna be using Lauren as an example. Now, this is just a story we found on the internet. So this is Lauren. She has endometriosis, and so what I'm going to do is I'm actually going to just read through her story right now. And on the screen, I'm going to pop up some things that might be showing up in a patient record when Lauren went through this experience. And so you start to get an idea of like where she might be generating data that might be in a data set. So Lauren says, I'd been experiencing endometriosis pain for 3 years, but was not officially diagnosed with endometriosis. About 3 years ago, I noticed my periods, which had been painful, were getting increasingly more painful. I started becoming aware of a sharp jabbing pain right by my colon and feeling tender and bloated around my tailbone and lower pelvis area. My periods had become so painful that I was missing 1 to 2 days of work a month. Painkillers sometimes dulled the pain, but usually didn't do much. I'd been in to see my GP about possibly having a cyst because I had felt a lump in my pelvis below my hip bone. My GP wasn't convinced, and she said that she couldn't feel anything on a pelvic exam. I finally convinced her to let me get an ultrasound just to make sure. The ultrasound showed a 4 by 5 centimeter cyst on my left ovary. My GP scheduled me for a scan in 4 weeks' time. However, before I had my scan, I awoke one morning in severe pain. My husband called 911, but despite the obvious pain I was in, the medics seemed unconvinced. I was eventually taken to hospital where I developed a very high fever and a very bloated stomach. However, I still waited for 3 days before eventually being given the scan, which showed an alarming amount of fluid in my abdomen. I was quickly rushed into surgery. Post-surgery, I was told that I did have endometriosis and that an endometrioma had ruptured in my left ovary and attracted a fluid to it. The fluid had become infected and was causing my high fever and pain. So that's Lauren's story. I know I actually didn't know a lot about endometriosis, and through some work that we were doing with Columbia, I learned that it is a horrible condition, and this is a quite typical story for a patient with endometriosis. Physicians not believing, and it's taking a long time to get diagnosed. But we're going to use her as an example today. Okay, so we have data, but how are we going to store the data? So each of you have raw data in its own format, so we need some kind of format. And the format we're going to use today is based on Cynthia. Cynthia is a synthetic patient population simulator. And what's really cool about Cynthia is that you can go in and simulate a data set that you want to use. So it's not real patients, but it looks realistic. And you can customize what you want it to look like. So this is not something associated with Odyssey. This is something that we found and we use within our tutorials. And Cynthia has a format that it follows, and so it has some simple tables, and so they're pretty self-explanatory. So you could store information about allergies, care plans, the conditions, the encounters, so those would be the visits, imaging studies, immunization, medications, observations, organizations, patients, procedures, and providers. So actually, it's not it's somewhere kind of in between a medical record and a claims set. And it's actually not too wildly different than the CDM itself. So I think it's a great example of how to think about an ETL. So on our VMs, what we have is we actually have a data set just for Lauren. So we have a database with just one person's records in it, but we've also, looking at one patient's records not gonna be great for all our examples today. We also have a data set that has 1,000 person sample in it. So one's called raw Lauren and the other's called raw Cynthia. But they all follow that Cynthia format. Okay, so here, when we're starting this to develop the ETL, we have tools. So we have White Rabbit. What White Rabbit does is it performs a scan of the source data. And what's nice about this is it's gonna provide you detailed information about what's going on in your database, telling you not only a little bit about the tables and the table structure, but it's also gonna tell you about what are some of the common values that are showing up in the individual columns. And we're gonna look at that. Once you have a scan in White Rabbit, you can pass that scan to Rabbit in the Hat. And so what you're doing is you're telling Rabbit in the Hat, this is what my database looks like. These are the values that I have for this data. You can load that into the Rabbit Hat and it provides you a graphical interface for you actually to build an ETL document. So we actually can connect the raw data to the CDM and start to say, okay, where is my drug data gonna come from? Where are my condition data gonna come from? Now, we used to say that Rabbit and Hat helps you develop a document, does not help you generate code, but people like Maxime are working on some work to, once you've generated an ETL, that it can actually start to write a little bit of a builder for you. And we'll touch upon that. Okay, so this is what White Rabbit looks like. It's got 2 tabs that we care about. The first is the Locations tab. And this is where we're gonna set up what data set it's gonna talk to. And White Rabbit can talk to a lot of different data sets. So it can talk to databases like Oracle, Postgres, SQL Server, but it can also talk to files. So if your data set is in CSV files, you can talk to it like that as well. And this is where you would set up where it's gonna actually make a connection. And then once you've made a connection to a data set, you're gonna scan the data sets. So you can determine what tables you want to scan. In most cases, you probably are just going to scan every table within your database. But if there are any Epic users in here, you probably wouldn't do that because there's a lot of junk tables in Epic that would take a lot of time to scan. So you might go through and cherry pick which tables you want to look at. Also really important in White Rabbit is there's some filters that you can set. So there is a min cell count that you can set. In some data assets, there are rules around the reporting that you can do around min cell count size. So for example, if anybody works with CPRD, you are not allowed to report any data of a cell size less than 10. So patient counts, anything like that, a number less than 10 is not okay. And so if you have those rules around your data set, you can set that in here. It's set by default at 5, but you can set it to whatever you need to. There's also a max distinct value. So we're gonna look at what the output of White Rabbit is in a minute, but one of the things it's gonna show you is what are some of the distinct values that are showing up in a certain column. And after 1,000, it's probably non-value add, but if you know, oh, I really need to see 1 million distinct values, fine, you can set that here. And then rows per table, this is how many rows it's actually gonna scan. So it's gonna take a random sample of your table and scan 1,000. The reason we do this is if you have really massive tables, you don't wanna wait 4 hours for White Rabbit to scan. But you could if you want to. You could set it very high and let it scan the whole table. This is just more, the rows per table is more of an efficiency thing, so you don't have to wait forever. Okay, so we've actually run a scan on raw Cynthia. I'm gonna walk through it now, but if you wanna pull up what the scan looks like, you can go into the GitHub, the tutorial, Under the materials folder, there's white rabbits. And then there's a scan report raw Cynthia. But I'm going to have it up on the screen as well, so you don't necessarily need to go get it. Okay. So what does a scan report look like? So when you get a scan report, it's an Excel document and it's going to have a bunch of tabs in it. The first tab is an overview tab, and what that is going to tell you is what are the tables that you scanned and what are the columns in the tables that you scanned. So for example, on the overview tab, there is, it's going to describe in Cynthia, there's a patient level table, and I can see all the columns in the patient table. So there's social security number, passport, birth date, death dates. And then White Rabbit tries to know a little bit about what's going on in the data. So like, what's the data type? How large is an item in this field? How many times is the field actually filled out? So you start to get a gestalt of like what's going on in this table. You might have columns that are just not blank. And so you've learned something. Oh, well, maybe this column, it's completely blank or mostly blank. Maybe I don't need to worry about importing it into my common data model because it doesn't seem to contain any information anyway. So the first tab is really an overview of what's going on in your database. And then for every table that you scan, there's going to be a tab. So for example, if I go to the Patients tab, it's going to now go through every column in that table and scan it and tell me what are the distinct values that I'm seeing. So for example, there is a column in the Patients table called race. Here are some of the distinct values that are being shown, and it's showing you the frequency that they're happening. So now when you go to do an ETL, it's telling you a little bit about what you can expect to see from those values. And you can learn things. For example, I have gender here, and I can already see that I've got males and females, and I can see how the database is doing it, which is common, M and F. Some databases do 1 and 0. Some say male and female. But I can also see that there are 2 people here that don't have any gender. And so now I can start to think about how do I want to handle that? And that's in 2 ways. Do I want to handle it in a certain way to put it in the CDM? Do I want to put it in the CDM to make it look a certain way? But also handle it because if your builder is expecting a value, the program itself is saying, I'm always going to see male and female, and then it hits this record that's null, you also don't want your program to completely crap out and be like, oh, I don't know how to handle that, and now I just stop. And so it's 2 ways. It's like what you want to put in your data. You also don't want the program to not be able to handle the situation. So it's very valuable. You can learn things that, like I said, like when you're doing a study, you probably have already filtered male and female at some point. You may never see those 2 people when you're doing a study, but when you're doing an ETL, you have to think about handling those 2 people. Okay, so now it's your turn. This is our first exercise. So on your VM, there is a shortcut on the desktop for White Rabbit, and it's to a folder. When you open that folder, there's a folder inside called bin, and you're going to look for something called whiterabbit.bat, and that's going to actually kick off the White Rabbit. So give everybody a second. When you open the White Rabbit, do you see a bin folder? Oh, so is it White Rabbit, bin? Okay, yes, White Rabbit, bin. Okay, anybody having problems with that? Claire, you're... Okay. Is everybody, I know we have one more helping over here. Anybody else need help? Okay, we'll keep going. So like I said, on the White Rabbit, there is a locations tab. And this is where you're going to tell White Rabbit where to talk to. So in this case, on the VM itself, there's a Postgres box running. So we're going to say data type Postgres SQL. And then the server location is localhost ETL. A lot of times you're going to probably be putting a server name or an IP address for your server. Then the username is Postgres, the password Odyssey, and the database name raw_Lauren. And when you put all that stuff in, you can test, and it will tell you, oh, I can talk to something, or oh, I'm not getting anywhere.
That's good enough connect to Postgres.
Okay. Anybody else need help testing the connection? Okay, so now that we've told it where to talk to, you can, we're gonna go to the scan tab. Now, like I said, a lot of times you're just gonna say scan all the tables, but if you have a data set with 1 million tables, you might wanna cherry pick. So go ahead and pick add all tables button. But one thing we need to do here, because we're scanning Lauren's data, there's not that many rows. So remember I talked about that min cell count size? If we set it to 5, we're not gonna see anything. So let's set that min cell count size to 0. That way we can actually see some of Lauren's stuff. And once you set it to 0, say scan the tables, and it will scan, and you'll see it. It will tell you what how it's going along. Now, normally, if you're connected to a pretty big data set, this might take some time to scan, and so White Rabbit will tell you where it is in the scan, what table it's on, so you can kind of have an understanding of where it is in the process. But this should go wicked fast for you guys. Hmm? So when it's done doing the scan, at the ends of the console, it will tell you where it put the scan Excel. So everybody go and open that scan Excel, because there's a pop quiz. Can somebody tell me what the most common condition Lauren has? I don't have a prize, I'm sorry. Yes. I'll let other people catch up before. Yeah. Is it? Huh?
It was candy if we needed a prize.
Oh, it's fine. Thank you. Okay, did everybody figure out how to do this? I've heard a couple people say the answer. Have people been able to open the scan report? I feel like you guys are a little sleepy. Is anyone paying attention? Okay. So we have lots of scan reports. So if, huh?
All of the conditions are different.
Yeah, but so one of the things.
Three of Menorrhea.
Yes. So, yep, you got it. So what the scan report's doing is it's going to show you the most frequent things first. So if you were to go to the conditions tab on Lauren's scan report and go, there should be a description field, I guess, around column K. You'll see that Lauren has 3 records for dysmenorrhea. So that's her most common condition. And again, when we're only scanning one person, we can attribute it to Lauren. If we were scanning the whole database, we can't attribute any column to anything because it's going to be what's most frequent in the data. But this starts to give us an idea of what are the things we're going to need to handle in our data. Okay, so like I said, White Rabbit creates this information about our database. So we've learned a lot about our database, not only for stuff for us to look at, but we've created this asset that basically describes what's going on in our database. So now we can use that scan and it can go into Rabbit in the Hat and inform helping us make our ETL documents. So Rabbit in the Hat can read the scan report, and it's going to provide us a graphical interface to allow a user to connect to the source data. It provides a graphical interface for us to connect our source data to the CDM. So I'm going to go through a couple examples, and then we'll do one on our own. But if you want to follow along a little bit, we already pulled out this scan report already. But you can go to the GitHub in the tutorial ETL, and you can pull out the scan for the raw Cynthia. So we scanned that 1,000 patients, so now we have that asset. And I think there's a question.
So in Excel, there's multiple frequency tabs there. So why is that happening?
So the question is, in the Excel, there's multiple frequency tabs.
In the conditions.
Yeah, so in that conditions Excel, there is for every column, there's going to be a frequency run. So if your conditions table has 10 columns, you're going to have for every column one of those frequency things run. So like, for example, if your conditions table has an ID, you'd see like, okay, these are the common IDs, these were the common birth dates, these were the common, but it lets you have a little window of what the data is. Like a really good example is if you don't know the codes that are used within, you'll see in the scan, oh, I can see they look like ICD-9s, they look like ICD-10s. So you start to know what I'm gonna have to handle when I get to the ETL. Yeah, so the question is what happens if the data sets are larger? So that's why in White Rabbit, we were able to set how much data we go grab. And what we found is that you don't need to scan the whole database to really get a gestalt of what's going on. So if you do you can take a larger sample than 100,000, but you probably might not want to wait for it to finish scanning billions of records, but you could if you want to. You just really need a gestalt of what's going on. And because it's taking a random sample, there's a good chance if there's something wonky, it's going to pick it up in its scan, even if you're only scanning a subset.
So the sample is always random?
Yes. But what you'll find is a lot of times, like even when you take the random set, it's like, okay. So if you want to follow along, we're gonna export this Excel. So I'm gonna do this myself in a minute. But before I start going into the VM, I'm just gonna talk really quickly about what we're gonna see. So when we work in Rabbit in the Hat, I'm gonna open the scan report in a second and show you. But the scan report is gonna pull up my source data in orange here. So these are our Cynthia tables. So if you had your own data asset, once you run your scan, your tables will show up here. And on the right-hand side, or I guess, I don't know, The blue is the CDM, and then you can start to draw from the raw tables to the CDM tables, and we're gonna work through that. So what I'm gonna do, and we could do it together if you want, I'm gonna work through the person table, the observation period table, and the condition occurrence table. And then what we're gonna do is you guys can try a drug exposure table on your own, and we'll also walk through how to generate the document. So we won't have finished an ETL in this case, but you'll have walked through the majority of the features of like how to connect things. So I'm gonna go onto the VM. Ooh, somebody kicked me off. Let me see. Need to reconnect. Okay. So I'm just gonna go to our GitHub so I can pull that scan document down myself. What did I say? It's in White Rabbit. So I'm just downloading the scan. And of course, if you were using tools, it would have just outputted from a White Rabbit. Okay. So now I'm going to go and open up White Rabbit. No, I'm going to open up Rabbit and Hat. Okay, so this is what it will look like when you just open it blank. And now I need to teach it about my data sets. So I'm going to open the scan report, which now I need to remember where it is. I think it's in downloads. So in this case, again, I'm sorry, I went File, Open, and then I'm just looking for where my scan document is. And once I open it, now I've taught Rabbit and Hat a little bit about my data. And so here's all my tables. What's cool is you can move them around. So again, if you had a big list and you want some things at the top to just help your work, you can do that. Same with the CDM side, you can move things around. And really, when we usually start this process, what we do is we tell people, before you dig into what's going on within a table, you want to dig into, like, you want to just start with what tables talk to what CDM tables. So, for example, if we're thinking about doing person, observation period, and conditions, what table do you think I need from our raw data set to talk to the CDM person table? Yes. So literally all I have to do is grab this arrow and connect it. So now what I'm doing in my ETL document is saying there, I'm going to feed the person table information from the patient table. I still have to tell you or tell the ETL document what's going to happen, but I've told it at a high level. I know that there's information coming from this table. Now, the Cynthia database is pretty simple, but you can also have multiple raw tables feeding one CDM table. So for example, conditions could come from multiple tables, and you're gonna wanna set up logic from all those different tables. For example, in the IBM data sets, there are 4 tables that conditions can come from. It's like inpatient admissions, God, I don't even remember, outpatient admissions. There's 4 tables.
Outpatient header, inpatient admissions, outpatient.
So there are 4 tables that have information about conditions, and they all look different. So I have to develop logic for all of those tables to feed the condition record table. So okay, so we started with patients, and yeah, we'll just start there. So, but typically when we're going through this oh, there's a question.
I just have a question about, like, in instances where you have multiple tables and then you have repetitive data, are you required to map those multiple times, or if you have it like once and the information's the same, is that enough?
Good question. So the question is, what happens when you have multiple multiple tables, or just in general, you might have repetitive data? And so we talked a little bit about this on that intro slide, where you know something about your data set that maybe a typical analyst doesn't know how to handle. You can choose, if you want, to handle that in the ETL. I would handle that. I would say, I know these are duplicates. I know the best records to pick. Let me just do it in the ETL. And now the new analyst that never knew why that is or how to handle it, you don't have to worry about them handling it anymore. So that's a perfect use case for your ETL. Now, we're not going to go through the full exercise again, but I just want to stress, before you dive into an individual table, you should try to map out what tables talk to what. We've only done one here, but for the example, it makes sense to dive in a little bit. So once I've done a map and I want to go in and define a little bit more, all I do is select and double click the arrow, and it's going to bring me into that table level information. So what it's doing is it's showing me on the orange side, it's showing me the columns in my raw patient table. And on the blue side, it's showing me the columns in the CDM person table. So I've said that this table talks to this table, and now I have the opportunity to say how these two tables talk to each other. So for example, well, let me talk through a couple other things. So just like on the table side, I can move these things around if I need. But now, because we've done that scan and it started to tell me a little bit about what's going on, if I click on ID, I can now see what the IDs look like. And so I can start to understand, do I need to have specific logic to handle this? So for example, here is the patient ID. And I notice that it is a character field, and I can see in here that there are dashes. Now I know, because in CDM, I want my identifier to be a number. I don't want an alphanumeric identifier. So what I've learned is that I cannot use the Cynthia IDs verbatim, because we want to facilitate fast, efficient queries in research, and using an alphanumeric identifier for a patient is not a good way to do that. And so I can see that in this scan here. So in this example, this still is the patient identifier. So I'm going to draw a line from here to here. But in a lot of tables, and you'll start to notice this pattern, there are also source value fields. So for example, there should be, where is it?
Under care site.
There we go, person source value. So in this case, person source value. In this case, I'm going to have a different identifier for a person in Cynthia than I'm going to use in my actual CDM. A lot of data assets just give their patients numeric identifiers. In those cases, your ID in the raw data for the patient is going to be the same as it is in the CDM. Now, so I'm telling the ETL, okay, this column is going to supply these two columns in the CDM, but now I need to give it, I can define more logic. So if I click on this arrow, I now have text boxes where I can define some additional information. And because the ID, I can't use it verbatim, I do need additional logic. So this is where I can tell my developers a little bit about what they might need to be doing. So I might say, auto number ID, and I don't know, match to source ID. And so, not that is very good, but basically I'm trying to tell the developer, you got to create IDs here. You just auto number them. I don't care how you do it. But then I'm going to be able to backtrack to my source system at all times, because I'm going to just store the value verbatim here. Okay. Yeah, question.
So you mentioned logic, right? So is that a scripting language you're using there, or what?
No, so right now it's this you can write whatever you want in this box. It's not going to then build code to go do something. What I'm trying to do is tell a human being what to go do. So at the end of this exercise, I'm going to generate a Word document. And then the words that I'm writing in this interface are going to just output into that Word document. Question?
Could you real quick summarize again why there needs to be two mappings here, one to person ID, one to source person?
So the question is, why are we mapping the ID from the patient table in the source to two columns in the CDM? This is a really good question, and this is going to be a theme that you're going to see in a lot of tables. So what the CDM tries to do is preserve what's going on in the source data, but it's also trying to map things to standardized terminology. So in this case, the IDs that come from the raw data are not, I can't use them. So I have to standardize them. But if I need to interact with my raw data set, the number one doesn't, the identifier of patient number one is not, I can't go and look that up in the raw data set unless somebody tells me what was the original value. So we store the original values, and really this kind of helps you get back to what was actually happening in the raw data. A better example, this probably become a little bit more clear when we do something like the condition occurrence. So for example, your raw data might speak ICD-9, and you get an ICD-9 code. And one data set might have an ICD-9 with a decimal place. One data set might have it without. You store it however your data set has it, you put that in the value, but then you're also going to be mapping it to a standardization, so like a concept ID. But because I have the value, if something goes wrong, I can actually kind of see like, okay, something happened here. I don't think it got mapped to the right standardization, but because I have what happened in the raw data, I can kind of back out of it. Sometimes where this becomes useful, some ICD-9s might map to a very vague or high-level SNOMED ID. But then for specific analysis, we will say, no, I really need to only have this ICD-9. And again, because we have the source values, you can actually say, okay, this is not preferred. I want to usually be standardized, but I can still back out to what was going on in the original data. I think it will become more clear when we get out of the person table.
So, just to make sure, so like in the source table, if you have row 1, where I guess the patient ID, just the ID column is like the number 1, for example. Mapping it to person ID doesn't mean like always copy the number 1 over to person ID.
Yeah, and so in this case, so the question is like, I've just drawn an arrow here, and because I'm not just copying the value verbatim, I gave the developer a little bit of logic of what to do. And I think, Claire, you
I just want to ask, but can you copy that over that number if you want, and if it's not like an identifying number for that person? Like, can person ID and person source value have the same?
Yeah, so like in Truven, for example, they just use numbers for their identifiers. So in Truven, my person ID and my person source value ID are the exact same field, the exact same value, because we can just use them. In this case, we can't because they're alphanumeric.
Question, so is there an option to store the mappings separately, or does it have to be inside the table, like the person table?
The question is there an option to store the mappings separately?
Your person ID that you generate and the original ID. Can you have a separate mapping table?
So the question is, could you have a separate mapping table? You could if you had a process that handled that maybe before you worked with the data. Yeah, you could, or you could just handle it within the builder itself. There's lots of like data tricks that you could do. So like if you had another identifier that you used somewhere else and you want to use it, you could have that as a lookup and get there.
Just build a separate table.
Mm-hmm. But then in here, you'd probably use it in your ETL process. Like you'd have that separate table and you could do the mapping that way. So for example, in that case, you might have two tables that talk to the person table. The mapping table, so you could get the ID, and then the other person table that maybe says where their birth date is and their gender and everything else.
Okay, I guess just my thinking, because this is a standard data model, so I should not be creating additional tables.
No, you should not be creating additional tables.
Exactly. So if I create another mapping table, this would be outside of the data.
Yeah, so the question is, should I be can we create tables outside of the CDM? And it's not recommended because then you lose the standardization. I mean, it does, I will admit that it does happen, and some people do that to facilitate other areas of work. But if you want to use, like, for example, the patient level prediction packages, they're not going to know about the ancillary tables.
Right, so there is no, sorry, so there is no built-in option to store mappings separately.
No. So like, yeah. Okay, so let's keep going. So the next field I need to do is gender concept ID. And just like with person ID, there's also a gender source value and a gender source concept ID. So I'll talk about that in a minute. So I have, luckily, I'll just move this guy up. Luckily, I have a gender column, so this is pretty easy. I can click on it, and again, we already looked at this, so I have males and females and then a few nulls, so I might need to think about what I want to do with the nulls there. So, okay, so I have gender. I want to map that to gender concept ID, and like I said down here, I also have gender source value, so I can store the verbatim value that I get, which in this case is basically M or F. And there's a gender source concept ID. I'll talk about that in a second. Okay, so that's pretty much where gender is going to go in this table. So now I need to apply some logic. So gender, we know in the source data it looks like male or female and null. So I need to tell it where to go. Now, a lot of times you're going to use the vocabulary to do a lookup. So if you're like mapping ICD-9 codes to SNOMED, you're going to use a query to get it from in the vocabulary from that code to a standardized code. But when you have these like onesies and twosies, you can usually kind of just put this in the document. So for example, Claire, I need your help here because I can now remember the concept IDs. I could just dictate to the developer, okay, when you see M, you're going to have 8507. Now, 8507 is the concept ID for male. I could go to Athena, or I can go to Atlas, and I could just search for this concept ID. And we'll do a little bit of that as well later. And then I'm also going to dictate to the developer that female is 8532. Now, I also have the opportunity to tell the developer what to do with those people who are missing gender. And I always feel like this ends up in a debate, but you have to decide for your data set what makes sense. So I operate in the world of claims. So the majority of the time when I don't see gender, it's not because somebody's changed their gender or is not disclosing their gender, it's an administrative error. And it happens so rarely in claims data that I can feel pretty confident I'm just going to drop the patients. I don't know all the research that I'm going to do at Janssen requires gender, so I'm not going to save 2 patients out of 160 million. It's just, it always comes down to, you do those attrition plots at the end and you'll be like, wait, where'd that one person go? Oh, they don't have gender. So they're not getting counted when I'm looking at males versus females. So what I usually tell the developers, if gender is null, drop patients. Again, this sometimes comes in a debate. I do know that there are data assets where gender being null means something. And then this is the opportunity in this package, you would tell the developer what to do with that.
Is it risky to hard code those values into your ETL process?
So the question is it risky to hard code those values? So there are certain concepts that are pretty consistent, like gender, or we're going to talk about types in a little bit. Those are safe to hard code. Like male's been male for the last 10 years. Yeah, male's been male for 10 years. So concepts in the vocabulary once a concept is created, unless we completely remove a vocabulary, like completely deprecate it, they don't go away. And a lot of these kind of like base concepts, like what's male and female, they're like core, or like inpatient, outpatient. These are just core concepts. So otherwise, 100% agree with you, don't hard code things. And we're gonna look about how to get it out of the vocabulary later. Any?
Just a time check, like 20 minutes until our break.
Okay, that'll be good. We'll do person and then we'll keep going.
And what if you want to keep the gender, the null gender? Is there like concept ID, is there a concept ID for null?
This is also something that gets debated. I hold the opinion, and the community can disagree with my opinion. But I hold the opinion, if I don't know how to define something or it's unknown, I like my concept IDs to either be an identifier or 0. So 0 is essentially, I don't know, there's no value here. And I like to keep concept IDs a value. That's because in my experience, I don't like putting nulls into the concept ID column because I believe nulls are the devil. I know that there are probably people in this room that disagree with that. It's more of like a, what DBA you started in. But that's how I would handle it. There's actually a whole thread on this discussion in the forum. People get very fired up, especially about the gender concept, rightfully so. So you can check out that forum discussion and contribute to it. But that's just my opinion.
Can I make just a quick
Yeah.
comment? So in terms of 0 versus null, wherever you fall on that side of that debate, every person has a gender, whether or not they have a M or F in their record. So we can safely map that to 0, meaning like there is something there for every person, we just don't know. Where like for a condition, if there's no code, can't say that that person had that condition if the code doesn't exist. And in that case, you could think about mapping it to a null. But every person has a gender whether or not it's reported. Is kind of how I think about it.
Okay, so we mapped the gender concept ID, and admittedly hard coded it. Then on the gender source value, I'm just gonna plop whatever the database gave me, so that way I could backtrack if I needed. And then there's this other column, which we're gonna start to notice this. There's a gender source concept ID. Now, this is not an easy one to start as an example. There are concept IDs in the vocabulary that there are standardized ways to refer to gender in databases, and there's terminology. So you could think about it, imagine if there was an ICD-9 for male and female, we could map it to that ICD-9 concept ID in the vocabulary. In this case, and in most cases for gender, the databases just make something up, and so they just put it in. So there's M and F isn't a standard like vocabulary that you can map to. So in this case, I'm sorry, this will become more clear like when we do something a little bit more standard. But in this case, there's M and F aren't standard. They don't have terminology in the vocabulary. They're just basically just random strings. And so I don't have something to map to. So I'm just gonna map this whole field to 0 because there's no concept ID for M and F. It's a little bit vague right now. It will become more clear. But in general, a lot of our fields kind of follow this mantra of there's a concept ID, there's a source value, and there's a source concept ID. Okay, let's just keep going. Year of birth. I should also say if I click on the CDM side, it will remind me about what I actually need in that column. So year of birth, I'm gonna guess probably from the birth date. Looks good, and actually it looks like I get full birth dates, so this is a nice data set. And so just like I've done before, I'm gonna draw a connection. But if I'm a developer, I can't just take this birth date verbatim because there's month and day in there too. So I gotta actually tell the developer, oh, and you could do this in words, or you could say, just take the year on the birth date. Or you could say, you just type it out to the developer. So you're just kind of giving the developer a little bit of an understanding of where to go. And then now birth date can also feed my month. And same thing here, I could say month, birth date. And then day of birth, we're lucky enough to actually have a day of birth as well. And day, birth date. Now I know year of birth is required because also a lot of research that we're going to be doing not only really needs gender, but it definitely needs year of birth. You really typically need to know the age of your patients in order to do research. I'm sure there are maybe examples where in specific data assets you might handle that slightly different, but in 90% of the cases, we really need to have a patient's year of birth. So this is also another example if we're missing year of birth, and it looks like we're doing okay here. I don't see any missing year of birth. I might tell the developer if birth date is missing, drop the patient. This is another place where I might drop patients because if I don't know if they're a child or an adult, I can't, it's really hard to do research on that. Okay. We could continue to do birth date and time. We know we don't have that from our scan, so I might just make a comment that this is going to be null. Death date and time, I'm going to, 6-0, okay. Yeah, we'd come back to this. Okay, let's do race concept ID. Okay, so help me here. Race is Hispanic, not Hispanic. No, ethnicity. Okay. So, okay. Let's start. So race. Okay. So if I go, so in the CDM, there's a race field and an ethnicity field, and I always flip these. So ethnicity is basically can just be two values, right?
For now.
Hispanic and not Hispanic. And then race is pretty much everything else. And this is because there's a standard way to handle race and ethnicity, and I'm forgetting the group that handles that, but we're mimicking it. We're mimicking a standard that's already existent. It's not something that we've set. There's a group that basically says this is a recognized race and these are the recognized ethnicities. Those are also concepts that are in the vocabulary that we can map to. So when I click on the source data and I look in race, I can start to get an idea of like what's going on in terms of race. So also, this is one area where usually within your data assets, you might have just one column for ethnicity, and ethnicity is going to be usually a mingling of race and ethnicity. So you would have to have some logic to say, like, if somebody says their ethnicity is Hispanic, that means I don't know what their race is, but I know that their ethnicity is Hispanic. If somebody says that they're Black, I know what their race is, not their ethnicity. So because I do have one data asset that has a column for both, so I could have somebody who identifies as Black and Hispanic. But in most cases, ethnicity just comes lumped all together, and we just kind of split it out.
Just as a note, we follow the OMB standard.
OMB standard.
Office of Management and Budget. For those.
Office of Management and Budget. So we didn't make it up. We are not trying to define race and ethnicity. But same idea here. I need to map it to race to its concept ID, and then race to its source value, and then race to its source concept ID. So in this case, this is where I need your help. Can you give me an example, Claire? Yeah, it's in, so I have to, ethnicity is a lump in this data set of both race and ethnicity. So this is typically what we see in the data sets. I don't think there's a separate race column.
There is, yeah.
Oh.
Yeah.
I'm sorry, I'm being very confusing now. Okay, so Claire, when you did the mapping, did we not map?
I think we just used.
You just use race.
And ethnicity go to ethnicity, and then ethnicity goes to ethnicity by itself, if that makes sense.
Okay,
Like race
I'm
goes to
sorry,
race,
I'm
and
being
then
very
ethnicity
confusing.
goes to ethnicity.
I have failed the tutorial. Just let's edit, undo the last 5 minutes and go back in time. So there is a race column in this data set. I'm sorry, please don't be confused. Okay, if I look in here, I can see the mixture of race and ethnicity. I see Hispanic and white, black, Asian, and Native. And so what I can do now is map what I was trying to do before and pretend it's what I did do. Okay, and so now in the race concept ID, Claire, can you help me out here?
So we have.
And this is one you would hard code.
What are the, can you remind me what the values are for race that we have?
Because you can see these are not standardized codes.
Yeah.
So they're just strings.
So if we start with Asian, the standard concept ID is 8515.
So again, I'm just dictating in this case what those text strings go to in terms of concept IDs. Let's do one more as an example.
And if we have white, it's 8527.
And these are also concept IDs that have been around for a long time. You can kind of tell because they're really short. So, okay, so you would continue to go through all the values, and again, we can see a lot of the values in here. You would continue to go through. If there are some, like if there's a misspelling and you can't tell what it is, you might just map it to 0. Or if there's not a concept ID for that race, you might just map it to 0. So you would continue to go through and look. Again, our race source value would just plop over as is. And this again is another case where those text strings are not standardized codes, so they're not going to have a source concept ID in the vocabulary. So I'm just, in this case, I'm not really going to do anything with the race source concept ID. I'll also quickly do just the Hispanic part for ethnicity concept ID. If I click on this, again, if I have, I would have logic that's basically is like Hispanic equals concept ID.
It's long. 3800 3563.
3563. And then else 0.
Or if they say not Hispanic.
That's fine, that's fine. You could there's some permutations you could go through with this, but just for brevity, if you see Hispanic, I'm going to map it to Hispanic concept ID. I think there was a question back there first.
So in that example, if your source data, right, if your source data had these codes as opposed to the string, right, that you would map that directly into ethnicity source concept ID?
Yes.
Okay.
So the question is, if the raw value was a code in that you could map in the vocabulary, yeah, I would map it to a concept ID. We're going to see examples of that in the condition table. It's clearer in the condition table. It's in the patient table. It's kind of, you're just getting these weird strings in here.
Yeah, but that leads to the question I was actually, so if it was that way, could you then not map directly from ethnicity into these hard-coded ones that you're doing, just use the vocabulary to traverse up?
So the question is, if the source value mapped to a concept, do you need to also map to these other like ethnicity concept ID? And the answer is yes. So all standardized analytics don't run off of the source concept IDs. Everything runs off of the concept ID columns. So basically, you're in the standardized tools, you're blind to those source concept IDs for the most part. Additionally, you could have, and again, we're going to see this more in the condition occurrence mapping, but you could have a code that maps to a concept ID, but it's not the standard concept ID. And ICD-9s are great examples of that. ICD-9s have ICD-9 concept IDs, but when you're doing the standardized analytics, you have to map that ICD-9 to a SNOMED. So we'll see that like in that case, I'll have a condition concept ID, that's a SNOMED, and then I'll have a condition source value concept ID, which is the ICD-9 concept ID. It's confusing right now.
In here, can you tell it, instead of going from the source directly into the kernel, right? Can you tell it, look, just the ICD-9 source concept ID is an ICD-9 code. Run logic that goes purple to purple, and then just, you see what I'm saying?
Yeah, so what I hear what you're saying. So he's saying, like, for example, if I draw an arrow from this to the source value, I could, instead of also drawing all these other arrows, I could just have logic here that says, okay, just look what value went into the source concept ID or source value and map it this way. It's just how you want to use the GUI. And yes, sometimes there's an annoying amount of arrows. So sometimes you might get creative in here of like how you tell the developer what to do. The ultimate goal is to just communicate what you want to do. And so if you can do that in a nicer way, you should do it. Question?
Real quick question about concept IDs.
Mm-hmm.
Why isn't like male just like 1 or 2? Like why is it like 4 digits?
Well, because, so the question is, why isn't male just 1 or 2? Well, because they're they're
So are concept IDs unique across all like?
concept IDs are unique across all things. So there might be other vocabularies where 1 and 2 mean something. So we need to have a unique identifier for every type of code that exists out there.
So given a concept ID, you can actually figure out if it represents a race, an ethnicity, a condition.
Given a concept ID, you know exactly what it is. And it's that way no matter what table it is. And in fact, actually, given a concept ID, you know exactly what table it belongs to. So if I look up male, it tells me, oh, this is a person, it tells me like its domain. And so I know where that concept gets used, essentially.
So that's the source column of, so you can use that last part, right? Below race.
Yeah, so we could also, so the question is, so in this data set, and I'm sorry, I was pretty confusing about this, there is race and then ethnicity. So I might build out some fun logic that says, okay, what do I do in certain situations? Because, for example, if you have 2 columns in this case, they might disagree with each other. One column might say, I'm Hispanic, and the other column might say, I'm not Hispanic. So you might want to write some logic, like, what do you do in that scenario? Do you do something with that, or do you just keep it the way it is? So you have to like look at your own data and decide how you want to handle. But you will always keep in the back of your mind, what am I going to ultimately use this for research? And if at the end of the day you don't do a lot with race and ethnicity, maybe you don't spend as much time worrying about how it gets pulled over.
Time check here.
Okay, so I know we are at time, so I'm just going to quickly go through. Okay, so let me just, we've gone through race and ethnicity. Location ID, if I know something about their location, I might tell it how to look up a location. Provider IDs or care sites, And then we've talked a little bit about, we would have also additionally done ethnicity and source value. So we've mapped one table, very high level. We could have gone into a ton more detail. And so I know that we are going to take a break now. So we'll let you guys have, if you guys could be in your seats before 11:15, that would be awesome. So go relax. If you have questions, we're going to be available for questions. And then we'll keep going through this exercise after we get back. Thank you, guys. Okay, so we did person. Now we're going to keep going. And we're going to do observation period. Oh, my remote desktop ended it again. Okay. Can you, what? Peter is the best advisor. I love my PhD. Erasmus is really cool. I'll just wait a second. Or should I wait? I guess I should wait. Oh, this is awkward. Is everybody doing okay? Is it too slow? Are you bored?
Maybe, are there any questions?
Are there any questions? Is anybody awake? Okay, one person is awake.
So you're doing all this with the scan file, and I know we generated a scan file for Lauren. Where did you get the scan file for Cynthia?
So the question is, where did I get the scan file for Cynthia? So I basically did the same thing I did for Lauren. I just scanned a different database.
Okay.
Mm-hmm.
Was there a way for us to actually?
Yeah, you guys could actually do the same thing. So in that location, you said, oh, I'm going to scan this database. And we said raw_Lauren. And you can actually, there's Cynthia's on the data. You could basically just scan that. And you could do it now if you want. It's very fast. Are we good? Did we figure out the mic situation?
Yeah, they're fine. Thank you.
Okay. Okay, so let's pretend we did everything that we wanted to do for person. Like I said before, you could probably spend an hour trying to figure out like exactly what you want to do. But if I want to go back up to the higher level, at the top here, I just kind of click in the white space and I'm going to go back to that table level. And so the next table that we usually think about is the observation period. And so observation period is supposed to represent when we believe we have observable time for a patient. And this is how you define time in your database is going to depend on the database that you're using. So I'll give an example of in claims data, time is actually very simple. In the US, when you enroll with an insurance company, you're essentially providing data for your entire enrollment period. And so when you have claims databases, they tell you, Erica was enrolled in March, and then she was enrolled in May, and she was enrolled all of 2005 and all of 2006. So I actually know every month if I'm getting data from that patient or not. It's very detailed information. In EHR data, it's a little bit less, it's not as clear how we would do that. So in EHR data, you sometimes have to think about what is the most appropriate way to think about time for an individual patient. Now, the simplest thing that we can do is just say, well, I'm just going to define time for an individual person as the first time I see them and the last time I see them. And sometimes that's as good as we can get. And we know when we're using a database that there's given limitations about how much information we actually know about a person. But I have seen EHRs that do a little bit more complicated logic than that. It just, you have to plan about what makes sense for your data asset. So in Cynthia, it kind of operates, we kind of are considering it in EHR data sets. And so when I'm going to define observation period, I'm going to say, okay, for a given person, I just want to find the beginning of their time and the end of their time. And so we can keep it simple, and we can say, let's use their records in the condition table to find the first condition and the last condition for every given person. Now, you could probably already see I can make this logic way more complex, but for this example, we're just gonna keep it simple. So I've drilled in now to condition table and observation period. And so now I have the observation period columns here. Now, one thing that wasn't in the person table, but is in pretty much every other table, is there's going to be an identifier for every row within a given table. So here it's called observation period ID. And so it's just an identifier for a given row. In most cases, you're not going to be using these IDs for a lot for research. It's just like as in a database, you kind of just want to like number things as you go along. So typically when I'm telling my developer, I just want to auto number this. So as you're bringing in auto number, oh God. As I'm bringing in data, I'm just going to count 1, 2, 3, 4, 5. And so if I have a million rows in the table, I have a million IDs. And now I have person ID. And so we know that in our case, person ID is actually a lookup because I can't use the verbatim ID. And so I can remind the developer that, okay, use the patient ID, but I might need to remind the developer, look up the CDM person ID in the person table. Because the identifier in here is not going to be the ID that we're using throughout the CDM. Okay, and now I can look for observation period time. We're saying we're going to keep it simple, and we're just going to say, when is the first time I see this person? So I'm going to just, I'm getting dates here for the conditions. I'm just going to say, take the lowest start, and that's going to be the start of time for my people. And then I might say, for the end, take the max end. And that's as good as I can probably get. Now, we also have period type concept IDs. And this is, again, it's kind of like the male and female. These are ones that we usually just hard code in. There's only a few types, and Claire, I'm going to ask you to help facilitate again. But usually the types are going to tell us a little bit about what type of observation period this is. So for example, in this synthetic data set that we're kind of treating like an EMR, we might call it
So this is period covering healthcare encounters.
period covering health care encounters. This is a concept ID.
And then the ID is 4481. 4724.
So I looked up, there are observation period types in the vocabulary, and I looked up in the types, and I just selected the one that made the most sense for my data. And typically, observation time is going to be of one type in a data set usually. Time is usually defined in one way. So this one's a little bit of a vague table. Do people have questions about this?
How do you define a concept for like start of diagnosis and end of diagnosis?
Okay, so the question is how would you define a type for start of a diagnosis and end of a diagnosis?
Right, and they're trying to do a parallel. So this is a period covering healthcare encounter, and then there are like diagnosis period encounter. So is there a different concept that defines start and end?
Yeah. So the question is, how do we know the start and end of encounters? So actually all we're doing right now is defining patient time. So we're a step above the actual encounter. And so from a database perspective, it's just knowing when you actually know about a person. So for example, when you define new users in a database, you typically say, okay, let me find their first drug exposure, but I want a certain amount of time before that index date to know that I knew something about the person before their index dates. This is what observation period helps you with. It helps you know about time for the person. So it doesn't necessarily dictate encounters. It just dictates, I have information about this person during this time. So you could think of a given person, let's say they enter your EHR in 2005 and they passed away in 2009. You can't use them in a study in 2015. Okay, are there other questions?
Can we just summarize just for the death date as the period end date?
So the question is, could we use the death date as the observation period end date? And yeah, you could make your logic a little bit more complex. So you might have an observation period that you censor at death if you have that information. For example, in the claims data, I don't think we do that. We just use what the administrative record says, but you can get as complicated or as simple as you need. But knowing that a lot of our methods rely on knowing the observable time. So you do need to spend some time thinking about how you want time to be in your data. And it can be complicated for some data sets. Another question?
So does that concept ID map to anything? A more generic question, are there instances where in a CDM there may not be representation in your data, but you're going to want to have it in CDM itself?
So the question is, how do I parrot that back? Are you asking, can there be different types of time?
No, as a generic question, are there instances where in a CDM there are variables that do not exist in your data set, but you need it or want it when you're converting it? So like right now, your period-tied concept ID is not mapped to anything, but you've kind of already defined it.
Yeah, so in this case, I'm just dictating it based on, I know my data is healthcare encounter data. So it's kind of the male and female kind of idea here. You're just looking in the vocabulary of what type of time you have. So if I'm in a claims data set, there are types for, oh, I'm telling you that the time I know it's administrative claims data. And so it's so I know that I have less limitation in that type of time than like EHR. It's like, oh, I don't really know when you're gonna be here. I just can see when you started and when you end.
So for this instance, this is more of like the knowledge you have about your data set itself, not something that you would
Yes, and
extract from
yes.
what is in.
Yes, so the question is this type is information that, because I have knowledge about my data set, so I'm dictating it. I'm not mapping something in the data set to this type. But I think the type field will become more understandable when we go into condition occurrence.
So why would you use the conditions table here and not the visit table?
We-
Because somebody
oh,
could have a start date.
we
and
could.
I've had this condition for 10 years, but that's not their period of healthcare encounter.
We could. So we could use all the tables and basically say, when's the first time I see you, when's the last time I see you? So we could say, I'm gonna look for the first time across all these tables. So you could do that. You have to, that's why we need a data expert, somebody to tell us. Somebody might say, oh, the visit table would be all you need because they would have to have a visit to get anything else. So you could start with that. That's a good question. Okay, I'm gonna go and, oh, well.
Sorry, but, so I see in the stop column, you have like more than half of the records like empty. So does it mean like just drop like those who are empty, like it's just stop?
I'm sorry, say which?
Just stop.
Okay, yeah, so that's what we can, yeah, good job. So in this case, what we're learning, the stop has a lot of empty fields. So maybe when I'm designing this, using the stop field as an endpoint is not a good way to do it. So you're exactly right. Like I would need to use the information that I know and using the scan to tell me, maybe this isn't a good field. So you're right, I did it wrong. You could do it a better way. Okay, I feel like it becomes more clear when we get to condition occurrence. So let's go into that. So condition occurrence, in this case, I think it's pretty clear that our raw data set has a conditions table. And so I'm going to just map the conditions table in my source to the conditions occurrence. And I'm going to drill in to learn, put more information in about that. So we're going to start to see the same patterns we've been seeing. So there's an identifier for the row. In every row that we write, we'll get an identifier. So I'm just going to tell the technical guys to just auto number it. I have a person identifier. We already know that this is a lookup from the person table. And now we get into our first official mapping. So condition concept ID. So we've been talking about we standardize what our source data is into concept IDs. And when we use our standardized tool sets, they're going to use things like condition concept ID. They're not going to use things like condition source value or condition source value concept ID. So I'm going to take a guess that what we want to map is in the code field. So I'm going to connect the code to the concept ID. And just taking a very quick look at this, I can see that it looks like I got some ICD-10s, right, Claire? So in here, I can actually do some mapping. I'm going to teach you more about how to go about doing this mapping in the next section. But this is where I would tell the developers how to filter the vocabulary to get the codes I want. So essentially, I'm just quickly going to say filter to ICD-10 and look up standard terminology. And you'll see in a later section explicitly what I could give to the developer to help filter a lookup in the vocabulary. And so that's going to map that ICD-10 code to a concept ID where we're going to do all our work. We have our conditions start and end dates, and it looks like we actually get starts and we get stops. And if I look at a start to try to get an understanding of what's going on, it doesn't look like we have time. But Claire, why isn't start at 6:00? Isn't date time supposed to be required?
It is supposed to be required, it's just not implemented.
Okay. Okay, so one of the, prior to 6:00 started using a date time field, because a date time field both includes the date and the time. So regardless if you have time or not, we could all use the date time field. There are some people who do get time, and time matters. It might matter when you leave the ICU. It might matter when the baby is born. Not a lot of us actually have time. And so one of the things that we will dictate and we can say is, we can, in this case, we don't have time. And so we can tell the developer, okay, take the date, set time to midnight. We don't have a time otherwise. And the dates look fine here, so that I don't need to really tell the developer how to handle the dates. They look like dates. I'm not too worried about that. In reality, so you see these little stars. This is telling me this is a required field. What I was just chatting with Claire about is actually in 6.0, condition start date time is now a required field. And in future versions of the CDM, this condition start date will be deprecated. So we're trying to have a soft cutover of rolling out those old fields without the times. Is that clear? Okay. And the similar work would go for the condition end dates. We already pointed out that a lot of these end dates are null, but we do have some end dates, so we'll bring them over when we have them. We don't need to infer them if we don't get them. We'll just take what they have. So for example, I don't usually get end dates, so 90% of the time my end dates are null. Now, condition type concept ID. So in the previous, we had a type of helping us to define what type of time we had in the observation period. We were saying that we basically had a medical record time. In the type field, it helps us preserve the provenance of where the data came from. So it's going to tell us a little bit about where in the data it came. So for example, if the condition is the primary code on a claim, I can use the type field in the condition type concept ID to help remember that that's where it came from. If I know it's a secondary code or I know it's a 23rd code, I can actually use the types to facilitate remembering that. In this case, in Cynthia, it just kind of looks like it throws the codes at me. So it's not really determining the difference between primary and secondary or header row versus more detail row. So Claire, could you help me and give me a couple examples of condition type concept IDs?
So we are using 32020,
Which?
is EHR and counter diagnosis.
And that's the only one we're using.
Yes, that is the one.
So in this case, because the data set's not really telling us a little bit more about what's going on with where this condition's coming from, kind of similar to the observation period, we're just saying, I know that this was an observation period diagnosis. In some of our EHRs, you might have this scenario, but you might also get some NLP data. And so you can imagine a situation where I might want to know the difference between the codes that are coming from the data and the codes that are coming from NLP that read physician notes. And so I can use the type ID to help me split them apart. And so there might be scenarios where I don't feel good about the physician notes, so I might use that as a filter to say, if I'm looking for a diagnosis, I don't want physician note diagnosis because I'm relying on whatever NLP algorithm that was run. Does that make sense? Okay. There's stop reason. So this would be if some data sets will tell you a little bit about the reason why a condition is no longer present. I don't think we have anything for that.
So for condition type concept ID, it could be like primary diagnosis or admission diagnosis, things like that.
Yeah.
Okay.
Yeah, and there's a whole, I think there's 100.
Yeah,
Maybe I should actually,
I would go to Athena real quick.
was it easier to do in Athena or
Athena.
Oh, you might have to tell me how to do it because I always do an Atlas. So do you guys know what Athena is? Athena lets us search the vocabulary. And so,
Choose a vocabulary and just search for condition type.
oh, this is much easier than Atlas.
Yeah, no underscore.
So what I'm doing is I'm searching the vocabulary for the condition types. And what I can see here is all the different types I have to choose from. So there's 118 different types.
You might want to put the standard filter on there, because that drops it down to 100, I think. Oh no, 118, you're right, I'm wrong.
So for example, I might have EHR billing diagnosis. Here I talked about NLP derived, so I could help tease out different types of conditions. This is where you'll see this is very claims focused. I have an inpatient detail primary diagnosis, inpatient detail first position. Some databases have primary and first, some databases only had first. And this goes on and on and on. Actually, can I make this longer? There's lots to see. You can do inpatient 10th, 15th, inpatient header, outpatient, it just keeps going on. So this is where the types actually start to become pretty valuable because it's preserving what was the information. And so if you need to kind of split it apart, then you can.
And can you have multiple types?
Can you have multiple types within, so you can have multiple types that exist within the table, but for a given, in this case, diagnosis, you'd want to assign it a type. If there's a case where you need it to have multiple types, I would then just write multiple records. That way it would come up in either case. Just because you have multiple diagnoses of breast cancer doesn't mean you have more breast cancer on the same day, right? Now drugs, that's a different situation. I wouldn't necessarily duplicate a drug because that would look like you're getting more than one drug on the same day. But in conditions, if it's happening on the same day, it's probably just all part of that visit. Okay. So we don't have a stop reason. A lot of data sets don't. If there was a provider associated with this condition, I could map to it. If there was a visit associated to this condition, I could map to it, or visit detail information. So visit occurrence would tell me if it's an inpatient, outpatient condition, and then visit detail would give me a little bit more information about the visit. It might tell me about the provider, it might tell me what care site I was at, what unit I was in the hospital. Now here's our, just like we've seen before, I have a condition source value, so that goes along with my condition concept ID. So I'm gonna draw the arrow here, and we can actually do something, and I'm going to show you a little bit more about this later. There are ICD-10 concept IDs. So now, in my condition source concept ID, I can map it to its ICD-10 OMOP concept ID, but then in the concept ID above, I'm mapping it to standard terminology, which is SNOMED. So in this case, the concept ID for the standard and the concept ID for the source concept ID are going to be different, and we're going to run through examples later. So again, I would just tell the developer map to ICD-10 concept ID. Condition status concept ID, if you have it. Okay, so we very quickly done 3 tables. And so I would like you guys to spend some time trying to do the drug exposure table. It's basically a mimic of what we just did in the condition occurrence table. And so what you want to do is think about what source table you'd want to map to the CDM. And then once you've selected that, drilling in and starting to map what columns map to what columns. So in order to do that, you're going to need to have that Excel. If you don't already have it, that's going to give you something to map with. You're going to open that scan report, and then what I'd like you to try to do is the drug exposure table. It's going to take a little bit of time to go through that.
We have 15 minutes.
Okay, guys, I just want to say a few things before we break for lunch. So I'll recognize that maybe not everybody went through the full drug table, and that's okay. The ETL documentation is completely online. I'll show you guys that in a second. But I did want to make sure before you break that I show you that once you've gone through and you've worked with the GUI and you've created all the logic that you want, ultimately what you want to get to is to generate a document, and I'll generate a Word document. And then what I can do is I can save this and then send it to my developer. So now my developer has documentation of how I think the conversion should go. I don't know where to put it. Hold on. I think in here. And so it just exports to a Word file, and now I might take this Word file and I might augment it from here and make it more clear now that it's in the document. Let's just finish up this section. So there are lots of resources for performing an ETL. I think the number one resource that you might want to use is the Common Data Model Wiki. So on GitHub, there is a wiki that describes all the tables in the Common Data Model and will describe what it's expecting. You may have also heard a little bit about Themis. Themis is a working group that's trying to develop standards around how we use the CDM. And so at the bottom of every table, there are recommendations for suggested rules of how we would operate. So for example, there are suggestions of what to do when there's multiple death dates. There are suggestions of what to do when there's multiple genders. So the CDM Wiki is a valuable resource to learn about what you might want to be thinking about when you're converting your data to the Common Data Model. I also want to highly suggest that the forums are a really great resource. Not only because there's been thousands of conversations, probably of the ideas and questions that you already have, but please do not be afraid. It is not a secret club of these super geniuses that are talking on there. It's just you and me and regular people who have questions. So if you have a question, just ask it on the forum. There are probably 4 other people who have the same question. We try, even though, for example, like Claire and I are active members in the community, we try to have our conversations instead of emails between us and Christian. We try to have those conversations on the forum so that everybody can learn. So if you have a question, just post it. You don't have to be afraid. You all know about the Book of Odyssey now, and you all have a physical copy. And so, again, this whole workshop is based on the chapter 6. And I quickly already mentioned there's a Themis working group. And so Themis is thinking about standards. And so they, if you have questions or there's a situation where we think we need to work it out, Themis would be one of the working groups to start to think about what's the best way to handle certain situations. If you want to see the full ETL, so you took a shot at your drug exposure table, you can actually see how we did the mapping at this link. So you can actually take a look at how our document was produced. And I want to have some parting thoughts on developing an ETL. We're going to talk about it more in the next section. But one of the things that when you're developing the ETL you need to keep in mind is that the vocabulary is going to dictate where some of your records end up going. So just like we saw in Cynthia that there's like a conditions table, that doesn't always mean that all those records will end up in the condition occurrence table. There might actually be some drugs in there, and the vocabulary is what dictates in the end. So the reason I want to bring that up is when you're thinking about your ETL, that might mean you might need to map your conditions table to the drug exposure table, because there might be some drugs that are conditions that actually are drugs. In this case, I have an example here. There's an ICD-9 abnormal weight gain. If you look this up in the OMOT vocabulary, I believe it's an observation. So instead of being a condition, it would land in the observation table. We're not going to go into too much detail about this second point. But for people who have been involved with ETLs in the past or are DBA type people, this might be a familiar concept. So there is a way within the White Rabbit and Rabbit Hat tool for you to map to something that we call a STEM table. So it's this idea that you can map all your data tables to this one big conglomerate table instead of mapping tables to tables. So what we've done is map the condition table to the condition occurrence table. From a programming perspective, sometimes it's simpler to think about mapping all your source tables to this big kind of landing table. What we found is that in the tutorial, it makes sense to teach the condition table to the condition occurrence table. But there is another option that allows you to map to this broader table. This becomes very valuable when you start to think about that because the vocabulary dictates where things go, you might not want to make all those individual condition to condition occurrence, condition to drug exposure. This might make the document a little bit simpler. I also wanted to talk about that the Hive is doing a lot of developments right now on, do you want to come and talk about it? I think this mic is active. I think this one is on, yeah.
So I want to highlight very briefly some developments that we're working on. First, to get credit where credit is due. I did not develop these ETL tools. That's mainly done by Martijn Schumi, who you might have heard talking yesterday. But we are, and that's from the Hive, but also within Eden, that's a European consortium, where we're going to transform a lot of data to the OHDSI CDM. We are looking into enhancing these toolings, so Rabbit in a Hat and White Rabbit. One of these that Erica already alluded to is generating some code from your Rabbit in a Hat mapping. Actually, we merged very recently into the code base, so that will be released soon. Then just two other things we're working on. That's adding additional metrics in the scan report. For instance, the fraction unique and the number of unique values per column, and also some additional numeric statistics. The other thing we're working on, and actually that would already come in handy maybe today, that will be concept ID hints. You've seen that, for instance, for type concepts, for gender, for race, there are a set number of concepts that you can use. In this case, for gender, it here says like we have two concepts IDs we can use, one for male, one for female, and these two are standard. And we're working on some smaller performance and user experience improvements. And actually, we're very open to ideas from you, from the general community. So that's maybe a nice thing to go into lunch. If you have ideas that could enhance this tooling, please come up to us and talk to us about it. Or go to the GitHub or Odyssey forum to add that if you think about things later.
Okay, thank you. And I think that will break for lunch. So I think lunch is from noon until 1. And I'd ask you guys again, if you can be in your seats before 1, I'd really appreciate it so we can keep moving along. And we'll go into the vocabulary mapping next. Thank you guys.